NASA is famous for its exploration and discovery in space. However, the agency is making discoveries under the Earth, right here on the planet. What has NASA discovered? How does it affect you? Join us as we dive deep into NASA's strange new discovery under Antarctica's ice. Join us in today's video as we go deeper into this. Watch! Few people have Antarctica as their dream destination, and that is understandable. Antarctica is the fifth largest continent, covering 5.4 million square miles, or 14 million square kilometers. However, the size varies through the seasons, as expanding to ice along the coast nearly doubles the continent's size in the winter. Almost all of Antarctica is covered with ice. In fact, less than 0.5% of the vast wilderness is ice-free. This place contains 90% of all the ice on Earth in an area just under 1.5 times the size of the United States. The place is so cold that if you throw boiling water in the air, it will instantly vaporize, because most of the particles will turn into steam, while the rest is instantly converted into small pieces of ice. The continent is divided into two regions known as East and West Antarctica. East Antarctica makes up 2/3 of the continent and is about the size of Australia. Ice in this part of the continent averages 1.2 miles or 2 kilometers thick. West Antarctica is a series of frozen islands stretching towards the southern tip of South America, forming an extension of the Andes Mountains. The two regions are separated by the Transantarctic Mountains, which stretch across the continent and are sometimes completely covered by ice. Is there plant life in Antarctica? Sort of. It is limited to a smattering of mosses, lichen, and algae. Seasonal moss coverage in Antarctica has increased steadily over the last 50 years. However, animal life is much more abundant despite the absence of amphibians, reptiles, and terrestrial mammals. Large populations of penguins, whales, fish, and invertebrates thrive along Antarctica's coast and frigid seas, especially in the summer. What about human life on this wide expanse of ice? While there are no indigenous people in Antarctica, you can find as many as 4,000 visiting scientists spread out across 70 research stations, braving the cold on the continent in the summer due to the harsh weather. The number drops to 1,000 during the even harsher winter. Antarctica is mainly a hub for climatologists, oceanographers, and marine biologists. However, the frozen desert also attracts astronomers from across the globe. If you can bear the cold, Antarctica is one of the best places on Earth to observe space. This is thanks to its dry climate and the absence of light pollution. Speaking of watching space, this brings NASA, the king of the outer universe, into the mix. What has NASA been doing in Antarctica? Looking down from the above, you might think the Antarctic ice sheet looks like a calm, perpetual ice blanket that has covered Antarctica for millions of years. Still, don't be surprised that the ice sheet can be thousands of meters deep at its thickest and hides hundreds of meltwater lakes where its base meets the continent's bedrock. Using the most advanced Earth-observing laser instrument NASA has ever flown in space, scientists have improved their maps of these hidden lake systems under the West Antarctic ice sheet and discovered two more subglacial lakes named Conway and Marker. The new study provided critical insights for spotting new subglacial lakes from space and assessing how this hidden plumbing system influences the speed at which ice slips into the Southern Ocean, adding fresh water that may alter its circulation and ecosystems. With NASA's Ice, Cloud and Land Elevation Satellite 2, or ICESat-2, scientists have been able to map the subglacial lakes precisely. The satellite measures the height of the ice surface, which, despite its enormous thickness, rises or falls as lakes fill or empty under the ice sheet. The study, published in the Geophysical Research Letters, integrates height data from the ICESat-2's predecessor, the original ICESat-2 mission, and the European Space Agency's satellite dedicated to monitoring polar ice thickness, Cryosat-2. Hydrology systems under the Antarctic ice sheet have been a mystery for decades. That began to change in 2007 when Helen Amanda Fricker, a glaciologist at Scripps Institution of Oceanography at the University of California, San Diego, made a breakthrough that helped update classical understanding of subglacial lakes in Antarctica. Using data from the original ICESat-2 in 2007, Fricker found for the first time that under Antarctica's fast-flowing ice streams, an entire network of lakes connects, filling and draining actively over time. Before, these lakes were thought to hold meltwater statistically without filling and draining. The original ICESat-2 mission is credited with discovering the interconnected systems of lakes in the icebed interface that move water around, allowing scientists to study all the impacts of glaciology, microbiology, and oceanography. However, with the ICESat-2, scientists had a powerful tool that yielded data so high in precision that they were able to start mapping out the lake boundaries on the surface. Scientists have hypothesized subglacial water exchange in Antarctica. Results from a combination of factors including fluctuations in the pressure started by the massive weight of the ice above, the friction between the bed of the ice sheet and the rocks beneath, and heat coming up from the earth below the thickness of the ice insulates that it is a stark contrast from the Greenland ice sheet, where lakes at the bed of the ice fill with meltwater that has drained through cracks and holes on the surface. How deep below the surface are the Conways and Mercer lakes? These hidden gems of frigid water are hidden between 1.2 to 2.5 miles, or 2 to 4 kilometers of ice on the southernmost continent. They fill and repeatedly drain largely mysterious cycles that influence how fast the ice sheet moves and how and where meltwater reaches the Southern Ocean. This flow in turn can change the currents in the Southern Ocean and potentially affect ocean circulation worldwide. Unlike most lakes on the surface that remain in place for years, this underground water system is dynamic or highly fluid, pun intended. By combining data from multiple satellites from 2003 to 2020, scientists have traced changes in the subglacial lake system between those years. They focused on 3 areas with good satellite coverage and known active lakes: the boundary between the Mercer and the Whillans ice streams in West Antarctica, the Lower Macayeel ice stream in West Antarctica, and the Upper Academy Glacier in East Antarctica. At the Mercer and Whillans boundary, the researchers found 2 new lakes which they dubbed the Lower Conway Subglacial Lake and the Lower Mercia Subglacial Lake. They also found that what was thought to be 1 lake under the Macayeel ice stream was 2. Over time, these lakes experienced major change. For example, the lakes beneath the Mercer and Whillans ice stream boundary have undergone at least 3 periods of drainage in 17 years. Meanwhile, all the lakes beneath the Macayeel ice stream have followed their own pattern of draining and filling. The lowermost lake went through 4 fill drain events during the study period, taking only about a year to complete. The second lake drained between 2014 and 2015 and filled up again, while the third lake drained just slightly between 2016 and 2017. Meanwhile, the lakes beneath Academy Glacier drained between 2009 and 2018. These changes are puzzle pieces in scientists' understanding of the speed and direction of Antarctica's ice sheet flow. Already, researchers are finding the links between the under-ice lakes and the ocean. In January last year, a study co-authored found that the drainage of 1 lake on the Amery ice shelf in East Antarctica flushed as much as 198 billion gallons, or 750 million litres, in the ocean in only 3 days, as reported by Live Science. While it is fascinating to find lakes buried deep underneath the ice in the Antarctic, one question you might be asking is whether there is life in that lake. The environment is harsh enough on the surface, but can life survive deep in the 2 newly discovered lakes? Expedition leader John Priscu, a professor of polar ecology at the University of Montana, answers that early studies of water samples taken from Lake Mercer show that they contained approximately 10,000 bacteria cells per millimeter. In comparison, that is only 1% of the 1 million microbial cells per millimeter typically found in the open ocean. It remains a remarkable find for a sunless body of water buried deep beneath an Antarctic glacier. But that is not the end, because the high levels of bacterial life in the dark and deeply buried are signs that it might support higher life forms, such as microscopic animals like tardigrades. Meanwhile, the abundance of bacterial life in Lake Mercer mirrored the discovery of high levels of bacterial life in Antarctica's nearby subglacial Lake Whillans in 2013 in an expedition that Priscu also led. Scientists theorize that the bacteria in Lake Whillans and possibly Lake Mercer survive on deposits of carbon laid down by photosynthesizing organisms between 5,000 and 10,000 years ago, when the buried lakes may have been connected to the open ocean. During their stay on the ice from December last year, the expedition team used drills and hot water to open a borehole from their camp at the frozen surface down to the buried lake of liquid water. The drill team bored through about 3,504 feet or 1,068 meters of ice. The water below was a chilly 30.8 degrees or minus 0.65 degrees Celsius, so that scientific researchers could take water samples and sediment cores from the lake, which was about 49 feet or 15 meters deep at that spot. The team had also lowered a specialized remotely operated underwater vehicle, or ROV, into the dark waters of the buried lake and several cameras, which they used to take images and make a video of the lake floor. The discovery has implications for the search for life on other planets, particularly on planet Mars, where signs of a buried lake of liquid saltwater were seen in data reported in 2018 by the European Space Agency's orbiting Mars Express spacecraft. In fact, Priscu thinks that any life below the frozen surface of the planet Mars might follow the pattern seen in Antarctica's subglacial lakes.